How's everybody doing? You guys hear me all right?
Hi, Professor. Yes, we can hear you.
Very good. You coming in some loud and clear also, Alexis. Or hey, how are you doing today? Give everybody a few minutes. Make noise. Oop. Oh, my microphone went away. Now I probably sound real bad. What happened to my microphone? Okay. Back to this microphone. I was playing with it and then it shut off on me. There we go.
Sounds better.
Yeah. I was trying to use my microphone off my Galaxies, my earbuds, and those aren't very good. So, all right. So what I wanted to go, I'm going to go ahead and get started because we don't have a lot of time. And if you'll notice, the final exam is over chapters 4 and 10. And that's going to be due on the 29th, which is next Tuesday, right? So we already went over chapter 4 pretty thoroughly, and most of you did really well on that exam. I think most of you got an A, or a lot of you even got hundreds on that exam. And that previous exam covered chapter 4, I'm pretty sure, right? So what I figured I'd do is go over chapter 10 today. What's going on Monday? You guys remember?
The paper and presentation is
Paper
due.
and presentation.
Yeah, we're gonna be doing the presentations, that's right. So hopefully everybody's ready for those. They're getting ready for those. And what I'll probably do is there's a way for me to give over control, right? So hopefully you guys will practice a little bit using Zoom and how to present on Zoom. Have you guys presented on Zoom before, Jorge or Alexis?
I have before for one class.
Okay.
I have as well.
Okay, so that should be helpful. I think most students have, so. All right, so let me begin. So I'm just gonna do some chapter 10 problems. And kind of just, we'll go through, we have till a little bit before 7 before I have to stop. We can do quite a few of these problems because they're pretty simple. So just let me go ahead and start out with some easy ones. So we'll do 10-1. And I'll open up Excel. Open a new workbook. And paste that in. Let me make sure you're seeing Excel. I guess sometimes Zoom is good at coming along with me, sometimes not. It looks like it is, right? So,
Yes, sir.
all right. All right. So let's just go ahead. We have we're given, and this has a. I like to do these like the cash flows. This is capital budgeting, so this is basically whether you want to take these projects or not. So we're given. So we have a time. We're gonna go year and cash flow. In year 0, we have a cost, right? And so that's negative and $40,000. That's what it costs in year 1, and then the project is going to go for 7 years. And we know the cost of capital is 11%. So that's how much it costs when we borrow that money. Right? We take a loan out and borrow $40,000, and then we're going to get some cash flows back. And we're investing, and then that investment, we're getting cash flows back from it. Could be a machine, it could be anything, right? Some kind of capital investment. And we want to know the NPV of the project. All right. So I'll do the solution. I'm going to do the solution the long way once, and then after that, we'll just use the NPV NPV function instead. So I'll do the present value of the cash flows. Oop. You guys have probably seen me do something similar in other problems. So we know this is already at time 0, so we're not going to use the interest rate at all on that. So we can do the present value this way and go equals present value. It asks me for the rate, and I'm going to pick 11%. I'm going to go ahead and hit F4 to put the dollar signs to make it absolute, because I'm going to copy this formula down. And the number of periods is 1 period. So I want to discount this $9,000 back, 1 period. And it's not, it looks like a payment, but it really, you want to look at it like a future value. So I'm going to hit comma and skip payment. And I want to make a positive answer. So I'm going to go negative to make this answer positive. And so 9,000 discounted back 1 year at 11% is that. So now if we just copy this down, then we can discount each one of these. So, you know, we look at this another way. If I invested $4,334.93 right here at year 0, if it earned interest at 11%, it would end up being $9,000. So you're basically discounting this 9,000 back to the present value. So now we can calculate the net present value. And it's simply the sum of all these. Okay. And it's probably a good idea to take it out a couple places. Probably a good idea to take it out to 2 decimals, because you don't know, you know, yeah, that case it wasn't even. Now, actually the easy way to do it, I would use the NPV function, and you just go rate. And NPV, you got to be careful, because see it says value 1. That should remind you always start at year 1, and then you add this back outside of NPV. You get the same answer. So you can see that the NPV function is a lot easier to solve that. Okay. I was just showing you what the NPV does, though. It just basically discounts all these back. What's nice about it, these could be not have to be 9,000. They could be any cash flow, and it'll automatically go and get them all. Now it all have to be timed evenly. If they're not timed evenly, you use something called XNPV, and then if XNPV, you'd actually have the actual dates of the cash flow, and it would give you, and then the interest rate, and it would give you the. So XNPV, you could even have uneven timed. That's beyond the scope of this class, but if you go here, go equals XNPV, it asks for the rate, the values, and the dates, right? So it's a little bit different. So you can have the time, you can have different values and different dates. All right. All right, so let's go ahead and do another problem. No problem, Patrick, about being late. Let me, trying to find my. Yeah. So let's do 10-2. Well, 10-2 is problem 10-1, right? Well, actually, all these problems are right in a row. They're all the same. We want to find the IRR, the MIR, the profitability index, the payback period, the discounted payback period. So we want to find all these. Let's go ahead and put these back in. We do them all. So these are all ways to do this. Okay, where'd it go? Seems to be giving me a lot of problems today. Yeah. Okay, so we also want to find, well, you know what, let's start a new one. And we'll get this data. Let me move this over to the right. Okay, so I'm going to call this 10-1. We'll call this 10-2 through 10-6. Okay, so I'm just going to say find these. Okay, so 10-1, they want to find for 10-2, they want to find the IRR. And IRR is actually very easy. I'm going to go equals IRR. And IRR, you don't even have to, you can remember NPV, I told you to start at year 1. IRR is different than this. You just highlight them all. It's assuming they're equally spaced and it asks you to guess. If you don't guess, it's just you put 0% in there. How did you just take whatever it gets? And we get 13.84%. By the way, what does this mean? I forgot to tell you what that means. What does that mean? Well, simply if that's above 0, that means that project is profitable. But then, because it's basically comparing this $40,000 and what all these discounted back to are equal to, because you're investing this. If you discount all these back to the present value, if these are more than this, when you discount them back, that means that it's a profitable. It's called the NPV and net present value, right? So IRR is another way you can look at these things, and at capital budgeting. Normally IRR you compare it to the cost of capital. So since this is higher than this, you would accept that project, right? So we can highlight that. That's the answer to the first one. And MIRR, well, you're going to do on that one, you're going to go equal MIRR. These are pretty easy. You just the function is the same as all three. Is the function is the same as the name of what you're trying to do. Again, the values, comma, then it asks for the finance rate and then the reinvest rate. Put the same thing for both of it. If it doesn't give you those, just assume they're all the same. It's all 11%. Again, we want to take that out a couple places. And then the next one we want to do is a profitability index. Okay, and the profitability index, let's go get it from the book. That's probably a better way to do that one. So let's go look at the book. Well, maybe I have it here. Hold on a second. I don't want to have to go around too much. Well, they don't give you the. Okay, I hear it is. I'm going to put the definition for that one in here so you can see it. So the profitability index is the present value of the future cash flows divided by the initial cost. Well, we have the present value of the future cash flow that's equal to NPV. And this is the rate. And these are the future cash flows. So that's the present value of those. You want to divide it by the initial cost. So the initial cost, we're going to go ahead and make it a negative because we want a positive number. So I'm saying negative this. And make that a number. And if that's greater than 1, that means you'd accept it. So this one's greater than that, so you'd accept it. This one's greater than that, you accept it. This is greater than 1, you'd accept it. So the profitability index, the decision rule is a greater than 1. Okay. The next one we want to do is a payback period. So for the payback period, let's just go ahead and copy these down. And what we want to do, we just do something called the running balance. And we're going to start out at 40,000. After 1 year, my balance reduces that plus that. So it's down to 31,000. If I just copy that down, I can see I've paid it back somewhere between the 4th and the 5th year. It's been paid back. So the payback period is equal to, well, it's negative in the 4th year. So it's 4 years of some fraction. So it'd be 4 years plus, I'm gonna make a fraction, but I want this numerator to be positive. So I'm gonna go a negative this divided by how much I get during the next year, which is 9,000. Again, we're gonna format that as a decimal. So it's 4.44 years. This is years. Let me put the years over here. Let me put the formula in here, formulas in here. Okay, now if these are all the same cash flows, you can simplify it. You can say it's equal to a negative this divided by any one of these because they're all the same, divided by 9. It's going to give you the same thing, 4.44 years. So that's a simple way to do it if they're all the same cash flows. Oops. Then all you have to do, whoop, then all you have to do is take that and divide it by one of those. So that's the payback period. By the way, that's that's probably my most popular video is how to do the payback period. I've got like over 250,000 views on that video. And do you notice it didn't even you don't need any knowledge of finance here, do you? You don't even use the interest rate. You just run the balance and calculate a fraction. So I've actually worked at companies that's what they use was the payback period because a lot of people, a lot of managers don't know any finance and they just said, well, let's use something simple that the managers can handle. So they use a payback period. So believe it or not, even though it doesn't take the cost to borrow the money into account, what companies do, they'll tell you they'll have a really low payback period, like 1 or 2 years. And then you can just kind of ignore the cost of capital. I work for a company. I work for a Fortune 500 company. You know what our payback period was on items as managers, on capital items I wanted to buy? Like if I put a project out, they use payback period. Back. What do you think, Patrick? How many years do you think? Oh, Pat, is Patrick there? Yeah, he's there still. Victoria? How many years do you think? I work for a company. You compare this, the company will say, well, you have this many, if you're going to do a capital equipment project, you have 3 years to pay it back. So this would not qualify, right? Because it took more.
Right, took 7.
You gave me 1 year, man, just 1 year.
Oh.
That's great. That's crazy, right? Just 1 year.
Yeah.
So I have worked for companies that are very, we would laugh at them like, how am I gonna buy a machine that pays itself back in 1 year? One thing is if you could prove it paid itself back in 1 year, it would be a good deal, right? So, all right.
Did you pay it back in 1 year?
What's that?
Did you pay it back in 1 year, the machinery?
Yeah, I had a payback period of 1 year for that company. This is a Fortune 500 company I work for. They use this capital budgeting methodology and they gave us 1 year. If that piece of if that machinery I wanted to buy, if it didn't pay for itself in 1 year, they wouldn't buy it for me.
I see.
The only time they'd buy it for you is if it was if there was a problem, like they couldn't meet customer demand and you need to buy another machine because the sales were already there for it, then they'd buy it. But if you just I wanted to buy a piece of equipment, you better have a good reason. So, all right, let's do the last one here, the discounted payback period. So I'm gonna go ahead and copy this again. I'm gonna do it over here. And the discounted payback period is very similar to the payback period, but then this one takes into account the interest rate, how much you borrowed it for. So we're gonna do the present value of the cash flows. And so I'm gonna go, so of course this one is already at the present value, it's at times 0. This one's equal to, well, I could do it this way, I could do it the way we did it here. It's equal to the present value. The rate is 11%. I'm gonna F4 that because I want to copy that down. Number of periods on this one is 0. And the future value, again, I want my answer to be opposite of what this is. So I'll make that negative this. And of course, it's 40,000. I copy it down. That's the present value of each one of those cash flows. And then I'm going to do the balance again. So you're just going to do additional columns. This column was not over here when we did this. So I'm going to do the balance based off the present value of the cash flow. So I'm going to go equals this plus this. And I copy that down. And you'll see this one takes a bit longer to pay it back because you're using the discounted cash flows now. So so now I would go the discounted payback period. Well, I'm going to put it here because you can't do this one. You can only do this one way. And it's going to be equal to, well, this one, the last is at 6 and some fraction, right? You owed a little bit at the end of the 6th year. And then you're going to get this much during the next year. So it's going to be equal to 6 plus a negative this divided by this. And then of course that's going to be yours also. Okay, so let me move this over so you can see the formula. Okay, so you've already learned quite a few ways to do capital budgeting. You learned the net present value. We learned the internal rate of return, the modified internal rate of return, the profitability index, the payback period, and the discount payback period. So that's 7 different ways, or 6 different ways, is it? You just learned how to do capital budgeting. And they weren't that hard, were they? So if you study this chapter real good, you should do good on the final. Okay? What do you think? You like those? Which one do you think is the most commonly used in businesses out of those 6?
Profitability index.
Actually, in my opinion, that's probably one of the least used.
Is it?
Actually, that's a good guess. This one, in fact, there's not even a formula. There's not an Excel formula for that, right? The one, if there's an Excel formula, that's a pretty good hint that that's probably. So the 3 that have Excel formulas are NPV, IRR, and MIR. I would say probably the most common is NPV, net present value. Okay, but you can see them all. Sometimes it's good to calculate it more than one way. The hardest thing about doing this is finding out what the cost of capital is, and usually you can call the controller for your company or whatever and ask them what number to use for a cost of capital. But and that's why a lot of times companies use this payback period also, because it doesn't need the cost of capital, right? So no, you don't even have to know what it is. You just make a short period of time. So anyway, let's keep going on some of the more of these problems. So here's another NPV problem. I'm not going to waste your time doing these because it's just doing the same problem twice, isn't it? I mean, you already know how to do the NPV up here. So it's just doing this problem twice. You do it for project A and project B, and then you do the IRR for both of them. And well, no, it does it more than, well, maybe we should do it because it does it several times. Let's do it. By the way, let's check some of these answers and see if we got them the same. 6.44 years, was that right? 6.44, yeah. Another one was 4.44, 1.06, 11. Those numbers look familiar to you guys? I think they're correct. 1284, 1193. Yeah, those are all correct. Okay, so let's go back to this other problem. All right, so let's do this one. And we'll go back to Excel. Let me move this over here. So we're given year 1, 2, and 3. And we have let me move this down. We have projects. I'll go ahead and highlight a cross here and merge and center. We have project A and project B. And so they both require an upfront expenditure of 15 million. So I have to copy this down. Put a year 0 here. This is an expenditure. I'm going to go in negative 15 and it's million 0, 0, 0, 0, 0, 0. And they both have, each of them require that. And then we have some other, we have 5 million, 5, 1, 2, 3, 1, 2, 3, 10, 1, 2, 3, 1, 2, 3. And then finally 20, 1, 2, 3, 2, 3. An extra 0 here. And then copy this. Paste it here. Copy that across. Copy it down. Delete, delete, 6. Okay. So we have make it look nice, I guess. Let me put the borders. And then we have different costs of capital. So we have cost of capital. We could say we want to find the NPV at let's put it here. We have cost of capitals of 5%, 10%, and 15%. We want to find the NPV for 5%, NPV for 10%, NPV for 15%, and we want to find the IRRs for all those. Okay. All right. So we just say IRR. IRR is independent of cost of capital. I think that's what they're probably trying to teach you there. Okay, so this is going to be equal to NPV. Well, actually, we could actually copy this across. That way it'll be easier. So we know both of these have the same, we're comparing them. So I'm going to go equals NPV. And the rate is this. And the values are these three values. Remember, you got to add the one at the time 0 outside separately, right? And what we're going to do, we're going to copy this down. So I want to F4 these. I'm going to F4 that because I don't want it to move when I copy it down. And I can copy it down. You can see that it's still stuck on those, but it moved on the percent. And I'm going to copy this to the right. The only problem is these have to move over to the right because I put a $sign on them. I'll move those to the right like that. I'll copy that down. So that's all the answers. And the IRR is actually real easy too. It's just like we did before. IRR, values and guess. Always take that percent out to 2 places. And that's the answer. So both of these are pretty good projects. You can see that you're investing 15 million. If you're just doing a simple payback period, you paid it back. You paid this one back in exactly 2 years, right? You invested 15 million and you paid it back in 2 years. This one, you invested 15 million, you paid it back in less than a year. You made 20 million back the first year, and then this is all gravy after that, right? So you can see these are both very good, but this gives you the actual value of these projects based on how much it costs you to borrow the money in each one of these interest rates. This you would just compare to this. As long as this is greater than whatever cost of capital you have, then your decision rule would be go ahead and take the project. So as you can see, you want to take those projects. They're all very so you guys like how fast you can calculate? We just calculated 8 things on Excel very quickly, didn't we? A lot faster than you would with a calculator or something. All right, let's do another problem. Oh, wrong thing. Where are we at? We're at this, right? Let's do some intermediate problems. Some of these I don't want to calculate because, well, yeah, let's calculate. Let's do it. We've already done all of these before. It's just doing them more times, right? Let's just look at the answer here. So you calculate these. You guys know how to do the NPVs and IRR, right? I already showed you on some other Excel sheets. So let's say we calculated them. So it says indicate the correct accept reject decision rule for each. Well, this is 409. Oh, you know what? Let me do it. Let me do it real quick. I want to show you a cool way to do it. So we're given initial outlay for the truck is 17. So year 0, the initial outlay is equal to a negative 17,100. And the pulley system is going to cost you a negative 22,000. 430. And then they both go for 5 years. And the first one is $5,100 each year. And the other one is $7,100. And it's the same thing for everything. And we know that the cost of capital, we have to borrow money at 14%. And I forgot what it wanted me to calculate. Let me see. Let me go back to the problem. Guess we could put the answer here too, so you see it. We want to find the NPV, the IRR, and the MIRR for each one of these. So for a solution, and decision rule. Now, we'll just say accept or reject. Okay, so let's calculate them all first. So the MPV is equal to NPV. The rate is 14%. It's these values. And add back the initial value of the initial cost. And that one, let me copy this over too so it picks it up. And the IRR, getting a little bit repetitive. And the MIRR. Oops. Okay, so what happened here? They put the numbers in wrong. Oh, this is 7,500. Help you if you put the right numbers in. Okay. And so this one we say equals if this is greater than 0. If it's greater than greater, you accept. Otherwise, you reject it. Can do the same thing for that one. This one would be equals if this is greater than that, you accept. Otherwise, you reject. And for this, the decision rule would be the same. We just copy it down. But now this has to be up to that again. So that's the decision rule using each one of these. Okay. Have you guys ever seen those if statements before? They're kind of handy. Very handy. Technically, it should be greater than or equal to, but I say if it's above 0, so or above. So we'll leave it at greater than. Okay. Let's do another one. So this one here, I'm not going to calculate these. These are going to do it very similar. But it talks about mutually exclusive. So it's mutually exclusive. That means one or the other. So in this case, when you calculate this, so it's very similar. They're going to cost 22,000. The other one's going to cost 1750. The cost of capital is 12%. They go 6 years. It gives you the cash flows. You put all that in, and then you calculate these the same way. I'm not going to insult your intelligence by doing it for you. So these are the answers you get. And you would pick the electric powered one because the NPV is higher, right? And they're mutually exclusive. You can't pick them both. If you can pick either, if you pick them both, then you pick them both. But mutually exclusive means one or the other. So I picked the one with the highest NPV. That's what it says. Project S has a cost of 10,000 and is expected to produce cash flows of 3,000 for 5 years. Project L has a cost of 25,000, 7,400 for 5 years. Calculate the, assuming what the project is selected, assuming they're mutually exclusive. So let's go ahead and look at the answers. So these are the answers you calculate. And let's just look at them. So NPV on S, so L is higher NPV. S has a lower IRR. Lower IRR. The profitability index is higher, looks slightly higher for S. When these are all conflict, I'm going to go with NPV because sometimes IRR is a little bit misleading. Okay. So I would actually select NPV. Let's see what the book says over here. See if it agrees with me over here in the solution area. Yeah, the book says what I do. Say it says, well, these are mixed like this. I would pick this L. Adds more value to the firm. Okay, they're both the same. Although L costs more money, but it adds more value. So if the risk is the same and everything else. Okay, company is considering these. They're equally risky. So So MIR, you guys already know how to do. You just go equals MIR or just highlight those. So I'm not going to show you that. So this is a gold mine. This doesn't look like anything too fancy. You calculate their NPV and IRR of the project. Of course, you'd undertake it. It says, how should environmental effects be considered? Well, you might have some type of cash flow costs at the end, right? Like maybe recovering the mine at the end, or it would be a negative cash flow at year 5 in order to return the land back to its condition. Mutually exclusive again means one or the other. Okay, so we calculate the IRR of those. So this is the IRR. So you go equals IRR and just highlight those and then enter, right? You get these. So it looks like B has the highest internal rate of return. So you probably pick B. If they're mutually exclusive, if they're not mutually exclusive, you pick both, right? If they're mutually exclusive, you pick project A, right? Because that has the highest NPV. Okay. So normally when they're mutually exclusive, you want to do NPV because it's easier to check. This is a little bit misleading because this says to pick A. But since if you use 10%, it would be A. If it's 17%, it would be B, right? So it kind of depends on the cost of capital. The internal rate of return, the definition of the internal rate of return is when the NPV is 0. Okay, so it asks you what the crossover rate is. So that's going to be a little bit trickier. So let's do this problem real quick. What problem was that? 1013. So we're given and we have year 0, 1, and it goes out for 7 years. And we have 2 different projects. A and B. And we have a negative 400, negative 528, negative 219, negative 150. All of a sudden I make 1100, and I make 820, and 90, and that's a negative 325. So this tells me there's 2 internal rate of returns. So there's 2 places in here where the NPV, since the sign changes in 2 places, and then this one's going to be equal to negative the negative 650, and that's 210 all the way down. Let's format these all the same. And You want to get, you want to construct. Let's go ahead and copy these in. I'm going to move that aside. And then this is what we want to find. Okay, so that's what we want to find out. All right, so this is something new that we haven't seen before. So we can calculate the NPV for each one of these. So let's just use this as the rate. So for part A, let's just say the rate is, start out, we'll say the rate, we'll do, let's say the rate is 10% just to start with. Answer part C. And we can calculate the NPVs. It's equal to NPV. This is the rate. And these are the values. Right? And we have to add back the initial cash outlay. And the NPV for the other project will be this. Well, we got to make sure we point to the same rate. So if it's 10%, it's an Npv profile they want to do for all sorts of different rates. So let's say we want to have rate, let's say we have, let me do it. I don't want to confuse you guys. I'm going to go down here. Go R, and I'm going to do something called a data table. Has anybody here heard of a data table before? Yeah, I haven't heard of a data table. Pay attention. These are very handy. So the way you create a data table, I'm going to put a bunch of different rates. An NPV profile is what the NPV is, a different cost of capital. So I'm going to start at 0%, and I'll go to 5%. Maybe we'll just do 1% at a time for now. We can change these later. We'll just do them at different percents. Let's do them all the way out to 25%. So I want to know the NPV. I want to know the NPV for each of these projects at all these different rates, at all these different costs to borrow money, to borrow this money that we're spending here. Okay, and also what are the costs to discount it back, right? So I'm going to go here. So you have to do it to do a data table. You have to do exactly the way I'm doing. So you put the rates here. So this is what I'm going to vary. And here is, I want to do NPV here. I want to point to where I've calculated NPV before. Okay. So I'm just pointing to those cells because I know I calculated NPV here before. And you have to put them exactly how I did them. So see how I did it across like that and then down. So I'm going to highlight all this. And I'm going to go to data, the data tab. I'm going to go to the what if analysis. I'm going to create something called a data table. It asks you, are your numbers you're varying, are they in a columns or rows? Well, they're in a column, so I'm going to put the column. And what are we inputting? We're inputting the R. Remember when we calculated these two things, we're using this right here. So this is what these are. And you could enter, it puts the numbers in. Now, what I'm going to do, I'm going to go ahead and format them all the same as above. So now we have the Npv profiles, and now what I can do, I can highlight the data to create the Npv profile. So I'll highlight them, and then I will go insert. Let's just do a scatter chart, like a smooth scatter chart. You can see this is called Npv profile. Okay. And we could go here on this chart. We can go up here too. As long as I'm clicked on this chart, I go into the chart design. If I click away, this goes away, that chart design. If I click on the chart, this chart design comes back. And I'm going to add some chart elements. I'm going to do axis titles. Primary or horizontal is going to be, we'll call it R, or the cost of capital. And then I'm going to go back here. I'm going to do a vertical axis title. And we'll call that, I'm going to go equal sign. I'm just going to click on NPV. And then we want to label these two colors here. So I'm going to go here to select data. In series 1, I'm going to click on it and go edit. And we know that's referring to column B, which we know is project A. So we'll call this project A. In this series, I'll go edit. And we're going to call that project B. Okay. And so now we know that this is project A and this is project B. Okay. So we probably could have gone a little bit further. Maybe we go by 2%. I'm going to change this from, I'm going to go by 2s. Just to get a little better look. So now they've crossed the axis. They both cross the axis. So we know the NPV, the IRR is where they cross the axis, right? So now we've done part A. This is the NPV profiles right here. That's part A. We've graphed them out. So part B, I'm going to put B right here. For B, they want to know the IRRs, right? So that's going to be equal to IRR. And we're just going to pick these values and then hit enter. Take it out 2 places. Copy it across. So there's the IRRs. And you can see that these cross the axis. This cross for project A, that NPV is 0 at exactly 21%, right? So if we go to, if I go by 1s again, well, I don't want to go by 1s. If I change this to a 21%, well, this is $12 is pretty close to 0. 12 cents is pretty close to 0, right? So there's a little bit of rounding error. If I take this out a few more places, it's actually 21.004%. So if you don't round it off, it's going to be 0. And then project B, the NPV is 0 if it costs you 25.844% to borrow your money. Okay. So that's part B. Part C, we want to know what the NPV is at 10%. Well, we have that right here. There's part C right there. And the NPV at 17%. maybe I should change this to 1. Let me go Control Z. We'll change this to 1s again. So here's the answer to 17%. That's what the NPVs are. And what was the other one? 10%. That's what the NPVs are at 10%. Okay, that's how we use that data to calculate that. So we've got part C, MIRR. Well, remember MIR is this equal to MIRR, and you want to do them at 10% and 17%. So we'll do the 10% first. We'll do these values. And the finance rate is 10%, 10%. Take that out a couple places. We'll call this MIR 10%. And I'm going to copy this across. I'm going to make sure that these point to 10%. And we'll copy this down. Change this to a 17. And these have to be, since I copied it down, I got to move them back up. Make sure everything's in the right spot. Okay, so there's the answer to part, that was part D, right? And then the crossover rate. Well, the crossover rate is right here where the two NPVs are the same, right? So the crossover rate for part E the crossover rate, well, we could say, let's do this. Let's say, okay, probably the easiest way to calculate this is I could go here. If these are crossing, the NPV is the same, right? So if these are the same, if I subtract the two, I could go equals this minus this, right? So if I subtract the two, it should be 0. So if these are the same, this is 0. So I could actually change this. I could change it to, I could see this is somewhere around maybe 16%. So if I change it to 16, should get closer. So let's change R to 16%. Okay, so it's a little bit less, maybe 15%. Okay, a little bit more, 15.5%. So I can actually guess this until this becomes 0. Now I can make Excel guess. I could go to data, what if analysis, and go to goal seek. And I could set that cell to a value of 0 by changing this R. And then if I go okay, it figures it out for me. It figures out that 15.54% is the crossover rate. And we could say use goal seek. Right? That's the answer. And then we need to change this back to originally was. It was 10%. Okay. And we could say we use goal seek on this, right? So, all right. So what's the significance? Well, if this costs a capital, I'd be indifferent between the two. If it costs me to borrow, if it costs me 15.54% to borrow my money, I'd be indifferent because remember, if I go here, if I make this equal to 15.54, if I make that equal to that, these are the same, so I'd be indifferent. The NPV is the same. So I would choose, if I was going to have to choose one or the other, I wouldn't care because this is the same. Okay, I'm going to go Control Z. So what the significance is at this rate, NPV would be the same for both projects. And I would be indifferent. Okay. So that's the significance. All right, so hopefully I didn't give you a headache there. I went over a lot of Excel there. I'll send you this file so you have it, all right? Is everybody still with me? How many of
Yes,
have you guys done capital budgeting before, anybody? Alexis, have you done capital budgeting before?
Yes, I have.
Okay, so this should be very familiar then, right? I might be boring you a little bit.
You're not boring, Professor.
That's good. All right, so anyway, so you learned, even if you know capital budgeting, I showed you how to do data tables. I showed you how to do an Npv profile. I showed you how to use goal seek. So you're learning some things on Excel too, right? That all can be handy if you're an MBA. Okay, let's look at see what else we have to work on here. I don't know why this thing is not jumping back and forth the way I like. Make sure you tell me if you don't see what's going on. Okay, this is kind of an interesting one. Let's do this one. So we have two different mutually exclusive, so it's one or the other. Plan A, Plan A. So we have we'll say this is a large scale, and it's going to cost $50 million. 1, 2, 3, 1, 2, 3. So that's going to be your 0. And it's going to have $8 million cash flow. 1, 2, 3, 1, 2, 3 for 20 years. So let's go 1, and we'll drag this down for 20 years. And we'll just click here and send this down. And then we have integrate, and we have what's the other one? Labor intensive. So the labor intensive plant, that's going to cost $15 million. So it's a negative 15, 1, 2, 3, 1, 2, 3. And that's going to give you $3.4 million for 20 years. Dollars, 3, 4, 1, 2, 1, 2, 3. And we'll send that down. And we know that R is 10% for both of these. And we want to calculate each project's NPV, and we want to find NPV and IRR. And later on, it's going to ask us for the change, right? So we're going to do, let me do a symbol here. We'll go insert. Well, you know, I'll do that down here. And then we want to find, how should I do this? I'll put question marks here. I want to find these 4 things. We already know how to do this. This is very simple. We'll go ahead and do it anyway. But this is something new. They want to find the project change. And they use a change symbol. I'll use the same symbol. We'll go insert symbol. And I already have that, so I'm just going to go insert. We know the project change. And then we want to know NPV and IRR for that. Maybe I should go NPV. Do it that way. And then we want to do the Npv profile. Okay. So for a solution, let's do it over here. We can do these pretty easy. Well, before we do that, let's just go ahead and let's do project change. Let's just copy this over again. I'm just going to copy all that, paste it here. We'll work with it again from here, and then I'm going to call this change. So I'm going to go insert, symbol, change. And this is just going to be equal to this minus this. Okay, we can copy that down. So we can do them all now. This is equal to NPV. And the rate is 10%. I'm going to go ahead and F4 that. And the values, remember, just start with 1. You have to add, on NPV, you got to add the initial one outside of it. And so that's the answer to that one and those two. And then we do the IRR equals IRR. That one we can highlight them all. Take it out a couple places. Copy it across. So you just answered 6 questions there, right? Okay. We actually answered all of this, didn't we? All right, so now we want to do the NPV profile. So the NPV profile is going to be very similar. We're going to go R. Okay, let's just go 0%, 1% for now, just kind of see how it goes. And we'll go out. We can go out. I don't know what this is going to look like. Let's just go out to 30%. And again, if we're doing NPV profiles, I want to go equals that. I'm going to set up a data table, so I'm going to highlight this. And then I'm going to go up here, I'm going to go to data. What if analysis, data table. Again, this is in a row, so I'm just going to be here. And what am I varying? I'm varying this 10%. And then we can copy the format, make it all dollars. And then I could do a graph. I can highlight this. In fact, I'm going to save this as a template. And we'll call it, so I don't have to do all the formatting again. I'm going to save it under I'm gonna save it in our class. I'm gonna save it in Dropbox. Classes. Summer, St. Thomas, FINA. We'll save. Okay, so I'm gonna go back here. This is problem 1015. Try that again. So I'm gonna highlight all this. We're going to insert charts. I could try to get the template. I haven't used the template for a while. Templates. I guess I should have saved it in templates. Should have let it do it. Okay, let me go back, cancel. Sorry, guys. So we'll let it save where it wants. Okay, now let's go back here. Try it again. And then I'm going to go to all charts, templates. Now I'll use this template. Okay, so it didn't do it quite the way I wanted. This is dollars. I tried. Okay, so I tried to use a template. There's ways to use a template. Sorry, guys, I thought that'd be worthwhile, but it ended up being too much work. So let me add this other. You know what I should have done? Well, I just did the Npv profile. I did the Npv profile for the change, right? Let me start from scratch. Okay. So I'm going to highlight this. Insert, cancel, insert. I didn't like the way it made that chart. So we'll just go scatter chart. There we go. This is Npv profile. And then we can go up here to select data, edit. So this is project, it's large scale, right? Because it's pointing to the F. And then we do this edit. This one's labor intensive. Okay. So there's my Npv profile. Possibly I should have done the Npv profile for the change, but I don't think it's really necessary. All right, so one thing that's interesting, this Npv, if I check it, I could go this equals this minus this, right? So the change in the NPV, it just is the difference in the two NPVs. But that's not the case here. IRR doesn't do that. Make that percent. So this isn't the same as that, is it? So the IRR doesn't work that way. What IRR is, that's actually this crossover rate. So the IRR is a crossover rate. It's the rate at which we'd be indifferent. So another way you could calculate this, if you remember, IRR, the crossover rate is where these two would be equal. So I can go over here, I can say this equals this minus this, just like we did in the last one. Then go to goal seek. And go to goal seek here. So I can go to data, what if analysis goal seek. And I could set that cell to a value of 0 by changing this rate here. And those things become the same. And if I cancel, whoop, let me do it again. I didn't want to cancel, I wanted to accept it. Goal seek. I want to set that to a value of 0 by changing my rate. That changes. I go okay. If I take this out a couple places, that's the same as what my change in internal rate of return is. So that's another way to calculate your crossover rate. That's the rate at which my two NPVs are 0. That kind of makes sense to you guys what I did there? I know I'm going kind of fast, but we're about out of time. So anyway, let me change this back to 10%. I just wanted to show you that subtracting these is going to give you this, but subtracting these is not going to give you that. This is actually the crossover rate. It's the rate at which these two are equal. So that's another way to find out exactly at that point right there. At what rate is the NPV the same, or would it be indifferent between the two different projects? So I'd be indifferent at this rate, 11. If it cost me 11.47% to borrow my money, my NPV would be exactly the same for the two projects, so I'd be indifferent. You guys following me there? So I showed you two ways to calculate. I used goal seek by subtracting the two and making that equal 0 until it came up with that. Or you can just do this change and do the internal rate of return, and that will give you the crossover rate also. What do you guys think? Sorry about confusing with the templates. Usually I have better luck with templates. I just wasn't having good luck with templates today. So, all right, so I have another thing going on at 7 o'clock. So if you guys have any questions on capital budgeting or on chapter 8, make sure you email me or let me know, right? I can make a video or something if you need me to explain anything.
Professor, I do have a quick question outside of chapter 8 for the presentation in the paper. How many slides, or is there a slide limit for the presentation?
I want you to keep the projects to about, at the most, oh, did I tell you how many minutes it's supposed to be? I don't remember. I don't want to change.
No, I don't think so.
I'd have to go back and look at the project directions again. I don't recall now what I said, but I wouldn't go, 15 minutes is too much time in my opinion to present it. Okay. So I would limit it to 15 minutes. How many people are on each team? Like 3 people, right?
Right.
So, you know, at the most talk 5 minutes each. And so that means as a rule of thumb, you don't want to put too much on the slide, and it should be like 1 minute for each slide. Okay. That's
Okay.
a good rule of thumb, right? If you put too many
Okay.
slides, you're not going to ever get it through it in 15 minutes. You would think you would, but I mean, it's pretty easy to waste a minute on a slide. Okay. So I would use that, but I'm not going to, I'm just giving you a rule of thumbs. I don't mark off for kind of things like that. You try it and see what you think, right? Don't go any
So
longer.
does this,
Don't go over any longer than 15 minutes. So,
okay, is the same thing for the paper, like a general rule of thumb, or do you have like something specific for the paper as well?
what's that, Alexis?
Do you have a specific limit for the paper as well? Like, does it have to be a certain length?
Again, it doesn't have to be huge. You look at it like an executive summary. And it doesn't have to be really long. I wouldn't be looking for, I'm not gonna be looking. I didn't give you page ideas on the, at all in the directions. I thought I did.
You gave us bullet points and you kind of did. So that brings me to my third and last question. So we covered a lot of different ratios within the textbook. So does it matter if we pick and select a select few to cover, or do you want to see every single ratio that we went over in the book?
You don't have to, you can, again, that's a guideline, right? So I just saw someone that did every ratio, man. So that's like overachieving, but if you want to do that, just select a couple from each area if you want.
Gotcha.
But at least try to stick to, when you go into that financial statement analysis part of the book, grab a couple from each section, right?
Okay.
But if you want to, like I say, I saw one where a guy he did one for everything. But he asked me if it looked okay, and I thought it looked really nice. So I don't know if it's someone that's on the presentation. I don't remember who it was now. But anyway, did that give you some idea? I know I'm pretty general, but I try to keep it.
No, it helped. Thank you.
All right. So I'll send this. I'll post this recording tonight sometime, and also post that that Excel file for you guys to look at if you want to look at it. All right. And that's it for tonight. I'll see you Monday.
Thank you. Bye-bye.
Bye-bye. Don't forget, you guys have to do those peer evaluations on each other too. All right.
Thank you.
All right, you're welcome. Bye-bye, Megan.